two long straight parallel wires separated by 0.75 centimeters are, so I'm going to do this, I'm going to do a little line here just so we know that the 0.75 refers to that distance, are perpendicular to the plane. As shown, the top wire carries a current of 6.6 amps into the page. What must be the other current magnitude and direction? So the resultant field at B is 0. Okay, so right-hand rule. So I'm going to assume that this is a distance of 1.5 centimeters. And so the formula we're going to focus on is magnetic field due to a line. It's going to be in a circle around the line, and it's going to be mu naught I over 2 pi r. And mu naught is like 4 pi times 10 to the negative 7th. It's just a constant. And so what we're going to look at here is it's going to create, so the right-hand rule, place your thumb in the direction of current, wrap your fingers, and so this is going to create a magnetic field going that way around the top wire. And the way I'm going to represent that is with a circle. And I'm going to do it like this, and I'm going to do orange because that's kind of what I started with, and I'm going to commit to that. So get rid of that random B in the middle. There we go. And I'm going to make this sort of centered on the X. And maybe a little bit smaller. Hoop. There we go. I'm good with that. So thumb in the direction of current, wrap your fingers. So the direction of the magnetic field created by this current is going to be this direction, clockwise. And so down here, magnetic field is that way. So now, looking at the magnetic field created by the second wire, let's do green, just for contrast. We're going to get something kind of like this. So there's going to be this circle magnetic field is going to create. And we want the magnetic field to oppose it, because that way when they oppose it, they'll cancel each other out. And so to have that, we wrap our fingers around the direction we want it to go. So we want this to be counterclockwise. So that means that it's going to have to come out of the board, represented as a dot. So that the mnemonic is, it's like an arrow. So if you see the dot, you're seeing the tip of the arrow. If you see the X, you're looking at the flechettes. That's the little feather things at the end. Yes. And so what we're going to say here is we're going to use our formula. And we're going to say that magnetic field, I'm going to call the top one 1, bottom one 2. And I'm going to say that total magnetic field equals B1 minus B2. And this is going to be at point P down here. The reason the negative is there is that just tells us direction. So the negative is just saying that the magnetic fields are in opposite directions, and we want this to be 0. Therefore, I'm going to say B1 equals B2. Really, they're opposites, but I'm going to go with this. And so we're going to have mu naught I over I1 over 2 pi R1 equals mu naught I2 over 2 pi R2. We want to find the current. What is the current magnitude and direction? So we decided the direction. The direction is going to be out of the board. And so we're really just concerned with the magnitude here. And that's going to be magnitude I2. So solving for I2, mu naughts cancel, 2 pi's cancel, and we get R2 over R1, R2 over R1 times I1, that's supposed to be an I, equals I2. Now normally I convert R2 and R1, well, first we're going to say that R1 is going to be this distance right here, which is going to be 0.75 plus 1.5, which is 2.25 centimeters. So they don't actually give us that. We actually have to kind of figure that out. We have to be careful not to mess it up, because it's easy to mess up. And it is surprisingly easy to mess up. R2 is just going to be this distance right here, which is 1.5 centimeters. And we're told that the first current is 6.6 amps. So I2 is going to be R2, which is 1.5, over 2.25 times I1, which is 6.6. Yep. And this will give us a number that is smaller. So I2 is going to be smaller than I1, which makes sense because I2 is closer to the point P. Therefore, it won't need as much amperage to create the same magnetic field. And this is going to be measured in amps. Now, normally I'd be worried I'd convert these to meters, but that's not necessary here because they're centimeters. It just becomes a ratio. They totally cancel out no matter what the units are. So 4.4 amps, which makes sense. It's about 2/3 of the value. So that's how I'd approach this problem. I know I probably did this a little bit more messy than I needed to, but 90% of this problem is the concept, about 10% math. So I hope that helped. See you next time.